All right. You can read that just barely. Here, let me determine if each is a polynomial. If it is, write it in standard form, state the degree and the leading coefficients. Okay. Should we start with 1?
Yeah.
Is that a polynomial?
Yes.
What's the degree?
So, or 1.
And what is the leading coefficient?
7.
Yeah, more importantly, positive 7.
Positive 7. All right.
Yeah, and even though the positive is implied when you say 7, the most important thing about that coefficient is whether it's positive or negative. That determines everything. Determines whether a parabola is going to open up or down. It determines the left hand and the right hand end behavior on all these polynomials. So the sign of that leading coefficient is really the most important thing. When they ask what is the leading coefficient, I would answer plus 7, or for number 3, I would say minus. I don't know, that's not even the highest degree in 3. All right, now the other thing they said is in standard form. Okay, is number 1 already in standard form, or do we need to change it?
Yeah, it's in standard form.
Okay, number 2, is that a polynomial?
Yeah.
Write it in standard form.
So g of x, or g and x equals, needs to be in descending.
I think it
Is,
is. Isn't that
yeah, I
9,
think that's in
6, and
standard.
5, or 9, 6, and 3?
That's 9, 6, and 5. Yeah, it is in
It's,
descending.
it's in standard form was the
Yeah.
answer I was looking for. The degree of the function
9,
and the coefficient.
3, plus 3.
Plus square root of 3.
Okay.
And I mean, if you're going to give the number, you could I worked with a student yesterday where the only thing when they said what's the leading coefficient, the answer was plus or minus. You couldn't even determine the size of it. But in your case, I don't know what your teacher, he probably wants the number also since he's giving you the function. But I would definitely put the plus square root of 3 with it.
Okay.
Number 3, is that a polynomial?
Um, yes, but it's not in standard form.
Okay, what is it in standard form?
H of x equals positive 4x to the 7th minus 8x to the 3rd, and then minus 9x squared plus 6.
Okay. And what's the degree?
7
It's the leading coefficient.
plus 4.
Good. Number 4, is that a polynomial?
Yeah.
No, it's not.
It is.
Remember what a polynomial needs. It needs all of the x's to be in the numerator, first of all, and they all have to have positive integer coefficients. So if I had a function like this, that's not a polynomial.
Okay.
Okay? If I had a function like this, that's not a polynomial because I can write that as, I can put x in the numerator, but then I have to have a negative exponent. So that's 1 over x, but that is not a polynomial. You have
Okay.
to have the x in the numerator, and it has to have a positive integer coefficient.
Okay.
So I guess once we write no, nothing else to fill out on that. Yeah.
Yeah.
All right. So now we're talking about end behavior. end behavior is, we haven't covered that before, have we?
No.
Okay. It's really not that hard. The only term that you care about when talking about end behavior is the leading term. So for this number 5, it's this term that we care about only. Okay, let me write it like this. That's to the 10th, correct?
Yeah.
Okay. When I'm looking at end behavior, I want to know left-hand end behavior, which is when x goes to negative infinity, and I want to know right-hand end behavior, which is when x goes to positive infinity. So whatever this curve looks like, I need to know what it's happening as x goes all the way to the left and all the way to the right. Well, if you want to solve it algebraically, just plug in the infinities in there. In place of x, I'm going to plug in negative infinity. Now, this may not be the way they teach you to do it, but this is the simplest way to think about it. They may not teach this because they don't like you acting like infinity is a number. It's not. However, if x is, I want to know what happens as x goes to infinity, I can get it by doing this method. Now, if I have negative infinity to an even power, what does it become? Correct.
No, if it's
Yeah. If I squared negative infinity, I would get positive infinity. If I cube it, I get negative infinity. In other words, if it's an even exponent, then they always are positive. If it's an odd exponent, a negative number to an odd exponent remains negative. So
okay.
the next step is -7. That doesn't change. Only this becomes positive infinity. In other words, negative infinity to the 10th became positive infinity. Now, when you take positive infinity and you multiply it by a negative number, what do you get?
Negative infinity.
That's the left-handed end behavior. And it seemed complicated, but here's the thing. If this is an even exponent, then the left-hand end behavior is the same as the right-hand end behavior. Notice that if I plug in positive infinity instead of negative, I get the same answer. I get negative infinity. But I automatically know that. If this is an odd number, this exponent, then the left-hand end behavior is opposite the right-hand end behavior. Well, we just figured out that the left-hand end behavior is negative infinity. That means the right-hand end behavior is also negative infinity.
Okay.
And what that would look like would be something that looked like this. Notice that as x goes to negative infinity, y goes to negative infinity. As x goes to positive infinity, y goes to negative infinity again. In other words, it comes up from the same side, it goes down at the end. It's like a parabola. A parabola goes the end behavior, and this is y equals x squared. Notice the squared is an even number. So if I were to plug in negative infinity or positive infinity, I can see that the end behavior is in positive infinity and both sides go positive infinity because it's an even power.
Okay.
Okay.
Oh, this is confusing.
Well, let's look at the rest of this problem.
Okay.
This subject that I just covered is confusing.
Yeah,
So all
I
you
don't know.
got to think of is substitute negative infinity and treat it like it's a number.
like, okay.
Okay? In other words, when we had, here's what we had, -7 x to the 10th. And we're trying to determine what happens as x goes to negative infinity. So just plug it in. That's all you have to do. Put it in parentheses, plug it in, and now treat it like it's actually a number. Well, if you had a negative number and you took it to an even power, it would turn positive. And infinities don't get any bigger. So you can square infinity, you can take it to the 10th power, it's still infinity. What is important is what is its sign? Well, its sign becomes positive because any negative number to an even power turns positive. So this step produces this step, and then if you take a positive infinity and multiply it by a negative number, you get negative infinity. In other words, treat it just like it's a number.
Okay.
Infinity is like 10. Only when you multiply it by something, it doesn't get bigger. It stays at 10. That's one way to think about it, kind of. But I think this is the easiest way to do it. Okay?
All right.
Let me test you. I'm going to give you another one. What happens as x goes to negative infinity? What does y go to?
Y goes to the.
Here's how you solve it. You stick in negative infinity for x. That's step one always. And then you got to figure out what you get when you take negative infinity and cube it. Well, pretend infinity is a number. What do you get when you cube a negative number? Do you get a positive or a negative answer?
Yeah.
Okay.
Negative.
So negative infinity cubed stays at negative infinity.
Okay.
Okay. Remember, infinities don't get bigger when you add numbers or multiply them or exponentiate them. They stay at infinity, but they might change signs. In other words, there is a difference between negative infinity and positive infinity. Now we got a negative infinity times a positive number, that's still negative infinity. So the end behavior, the left hand end behavior, remember there's left hand and there's right hand. Left hand is when x goes to negative infinity, right hand is when x goes to positive infinity.
Okay.
Okay? So let's answer their questions.
So f of x
goes to what as x goes to negative infinity?
F of x goes to f of x goes to positive infinity.
Let's do it again. X. Let's do it again. We don't care about these two other terms. The only term we care about is the biggest one. We did this one. First step, what should I do?
Put negative infinity in the x.
In parentheses.
Yeah.
Because it's only what's in parentheses that's being taken to the 10th power. Now do the exponential part first. That minus 7 is not being taken to the 10th power. It's just negative infinity. What does that turn into?
Positive infinity.
All right, so the next step is to put positive infinity in there. We don't need the 10th power anymore. Now you have infinity times a negative number. What's that equal to?
Negative infinity.
Okay, that's our left-hand end behavior. So that is negative infinity. Now, I could do exactly the same process, go through it and stick a plus infinity in there to look at right-hand end behavior. But there's an easier way. If I'm looking at an even exponent, my right-hand end behavior is the same as my left. I know immediately that it has to be negative infinity.
Okay.
Okay. If it's an odd, then I would know that it has to be positive infinity. In other words, they would have to have different signs.
All right.
So getting the second one is easier than getting the first one. And I wouldn't necessarily have to get the first one by plugging in negative infinity. If it's easier, plug in positive infinity. In other words, figure out the right-hand end behavior first. And that is probably easier because you're not dealing with negative infinities. You're dealing only with positive infinities at first. So I would say let's do it that way. Okay?
Okay.
In other words, let's do the right-hand end behavior first, and we will avoid having to plug in negative infinity for anything. What's the term I need to use here?
Positive infinity.
Well, hold on. There's only one term, and number 6, I'm sorry, I always think you can see where I'm pointing. On number 6, which term is the only important term to determine end behavior?
2x to the 7th.
Okay. Now, let's figure out right-hand end behavior first.
Okay.
Tell me what to do.
We have to put positive infinity in parentheses next to the 2. And then it turns into negative.
How? Positive number taken to an odd power stays positive.
Yeah. All right. So it's positive.
Now, with positive infinity, already it's easier. We don't have to care. In other words, that's never going to turn negative. So we now have 2 times infinity, which is infinity. So we know that the right-hand end behavior is positive.
Okay.
Okay. Now we also know that this is an odd number, 7. So what's the left-hand end behavior?
Negative.
Exactly. Opposite of the right. And that is much easier. I don't know why I did it the other way. There's no need to ever substitute negative infinity. You should always figure right-hand end behavior first, because this doesn't change whether it's to an odd or an even number. It could be infinity to the 6th power and it would still be infinity. Now it does change if it's multiplied by a negative number, but this is not, so definitely a lot easier to check right-hand end behavior first.
All right.
All right, we ready to go on to different subject? Scientific notation. You have your calculator in front of you?
Yeah, I've got one.
You don't really need it now that I look at these.
Okay.
Forget it. Let's not use it, in fact.
Okay.
So when you're multiplying, first of all, there's a rule on scientific notation. This number has to be between 1 and 10. It has to be greater than or equal to 1, and it has to be less than 10.
Okay.
So 10, I would turn into a 1. But 9.999 would be okay. Okay? So when you multiply these two things, multiplying them together is pretty easy. You multiply the front parts and you multiply the second parts, and that's it. You don't FOIL them. You multiply these two numbers, and then you multiply those two numbers. And that's your answer, or at least that's partly your answer. It's not the final answer, but that's the mid answer. So it's 5 times 6 is 30 times 10. Now you're multiplying, what is that, 10 to the minus 20th?
Yeah.
And that's 10 to the 13th?
Yeah.
So that's what you're doing, is you're multiplying the same base, 10, to different exponents. What do you do with the exponents?
You just combine them, right?
Add them. You don't combine them.
Okay.
you add them, because combining them doesn't tell me whether you multiply them or add them. So you
That's
add them. That
100.
makes it 10 to the minus 7th. So that's what the first exponent is. Or that's the exponent, but I'm not done. Because now that 30 is not between 1 and 10. The 30's decimal point is right there. So if I want to move it to the left to get it to right there, I'm moving it one spot to the left. Means
Okay.
I gotta add 1 to this exponent. When I add 1 to negative 7, I get negative 6. So the correct answer is 3.0 times 10 to the negative 6. So after you do the multiplication, if that first number is not in the proper range, then you always have to move the decimal point. And if you move it
Okay.
left, you add to the exponent on the 10, and if you move it right, you subtract 1 from the exponent. So let's do number 8. What's 2 divided by 8 in decimal form?
2 divided by 8 is 4.
It's 1/4.
Wait. Oh, yeah, okay.
In
1/4.
decimal form, that's 0.25. I'm going to write it in decimal form. It's one of the few times in math where I like decimal form. Okay? Usually I don't like decimal form, but in scientific notation, it's critical. Now, what's the exponent?
3 and 20.
What do you do when you divide the bases?
Subtract them.
Okay, so what's my exponent?
So 20 minus 3, or
Oh,
no,
3
3
minus
minus
20.
20 is negative 17.
Okay. Now again, that first number is no longer in my scientific notation range. What do I have to do to the decimal point in order to get it in?
You gotta add 1 to the, or you just gotta move it over 1, but then you have to also add an exponent to.
This time I'm moving it to the right. That means I gotta
Oh, so it's subtracting. Okay.
do the
So
opposite.
then it's 2.5 times 10 to the negative 18th power.
Yeah. Now, let's see. We got 3 minutes, enough time for me to tell you how to not ever forget which way you go. Take a number like 20 times 10 to the first. What's 10 to the first?
10,
Okay, times 20 is what?
third, or 200.
Okay, so if we know that if we wanted to put that in scientific notation, we know we got to move left, which makes it 2.0. And if I forget, do I need to add or subtract? Well, I know that needs to be a 2, right? In other
Yeah.
words, 10 squared is 100. 2 times 100 is 200. So to be the same number, when I move the decimal point left, I got to add 1 to the exponent. And when I go the other way, I got to subtract 1. And
Okay.
by using a method like this, where you're dealing with very small numbers that you can convert to their true number, so you can know exactly what has to be done. In other words, to change 20 to 2, you have to add 1 to the exponent on the 10.
Okay.
Okay? Britt, I gotta run. Talk to you next time. I think it's tomorrow, isn't it?
Yeah. All right. Thank you. Appreciate it.
Bye-bye.
Bye bye.